breakthroughs through your questions. And hosting this part today is Dr. Doc Van Huân from Vinotech. Besides the panel discussion, we'll have the presentation of Mr. Moon Chun Lim from Materialize, Ms. Sally Chuyên from Create 3D, and Mr. Gary Tang from Nicom SM Solution. Please welcome the hosts and also the panelists on stage.
Sally, do you have any point to add?
Yep. So I think concur with what Juan said. I think it's true that when you are investing in such a huge technology and it's expensive, you don't want to risk it. So I'll just give an example, and this is a couple of years back where we were trying to print an impeller in Canal 718. So the design of the impeller is such that it has to be placed at a certain angle in our chamber. And of course, only after we printed everything, then did we realize that there is some deformation, obviously unexpected thermal stresses. We obviously wouldn't know until the full product was printed. So, and I think to Juan's point is that, if there was a software, whether it's Simulfact or something else, that can help to simulate and then kind of predict or at least simulate where are those areas where there's possible deformation, where the thermal stresses are going to be more concentrated, then we know what to do to anticipate the printing. And I think that's where whether it's the support structure design, how we position it in the chamber, and how we also vary with all the multiple parameters that's affecting the print within the chamber. So I do agree that, especially if you are going into production, the simulation it is a upfront cost initially, but that cost will help you to then be able to mitigate the downstream risks and unexpected events that you probably wouldn't know if you didn't have the simulation process to begin with.
I think for plastic, I do a lot more plastic than metal. In the past, if I'm not wrong, the traditional simulations is done by injection molding simulations, right? If I'm not wrong, yeah. So it's not exactly accurate for plastics. So frankly, I've never used any simulation software for our own printing. I personally don't think that injection molding simulations is similar to FDM printing. Yeah, so for metal, it's a bit different. It's different because metal is homogeneous. For part strength, X, Y, Z, I can't really say for plastics, yeah. So plastics, if let's say plastics, I would say we still have to use our own experience and knowledge to, generate all these designs, fortunately.
Yep, I think, thank you for your point. So I think in now I think I want to just one step.
Dr. Kumar, just want to add, can I add one more point here, Dr. Kumar? Okay. So
Yes.
We talked about the accuracy. Actually, today we have something called compensation. Okay. The software is in a position to say, okay, to fit it within the tolerance. One is a 3D printing, okay, but at the end of the day, after you remove all the support structures, everything, you do machining, whether it is able to fit the tolerance, okay, because for example, in the afternoon we'll be talking about medical and other things where the tolerance is very, very required, okay. If you are talking about microns and at that level, so in our software we have the compensation, okay. After you build, after you remove it, the software is going to tell you how much is actually the error is going to be. So instead of you can put a negative of the error, then after you print it out, it can give you multiple iterations to come out, okay, what will be the final shape. Okay, so it is possible, the technology is available that even before you print it, you can apply the compensation, okay, and the part is printed in a way, or the design is done in such a way that the printed part is, within the tolerance after you remove all the support structures, everything. That's number one. The second thing is, after you print it, there are many times you may have to do some, drilling something, okay. I have seen customers, okay, they do 3D printing. After that, they create certain holes, just to drill some holes because of already the stresses present due to all the thermal distortions and other things. When you drill a hole, then the cracks appear. Today, the technology is available that you can even predict what will happen to the machine stresses. So from there you can go to the 3D printing. Then you can think about all the compensations, orientations, everything. So you can look at the end part, finished part, then you can drill down onto various aspects of it. Today the technology is available and we can provide all those things there.
Thank you so much. But I think that is also a good point. So the Simulfact additive software, I think the reason why it can be quite accurate is because it's integrated between simulation and the actual machine. So there's a kind of compensation and this using the actual use cases, and then it compensate so that it can generate very good result. Different with the traditional simulation software, normally is built by mathematical model to things like finite element method to run the simulation. But for Simulfact additive, I think they have another layer of compensation between the machine and the software. That's why it serves the purpose. Yeah. So now let's talk about 3D printing itself. So when people talk about 3D printing, normally people only think about, put something in the 3D printer and it print, and then you take it out and that's it, right? But actually it's not the case. So for 3D printing, this technology actually not a new technology, right? It's been there for like more than 30 years, but it only emerged recently, especially for the last 10 years. So for this technology, it's still expensive technology to use in terms of material, in terms of machine. But from the perspective of OEM, what do you think the future will hold for this technology in the next 5 to 10 years?
Well, I think it's just a matter of time. It's a matter of how fast, sooner or later, where companies across sectors, industries will have to adopt 3D printing. I think there are already many research reports, surveys that shows that one of the key things why people or why companies do not adopt AM is because of the lack of knowledge, the lack of awareness. It's the fear of the unknown or the uncertainty. And that's one of the key reasons in those reports that shows that why companies are very hesitant to step in. But on the flip side, you see those companies who are in the leading early adopters. They're in the lead. They are fast to jump into 3D printing. If they own the design rights, if they have the product that they know how to design for AM. The same thing I refer back to. Maybe I'll use another example. Say in one of the slides that was shown is BMW. So BMW obviously is a very established, luxury car company. So one of the examples was there was this. It's not a critical part, but it's one of a hinge which was done in traditional molding in plastic, and that was converted, designed for AM into a metal hinge, and that metal hinge actually was lighter, stronger, and a longer lifetime than that original so-called polymer hinge. And how is that possible? It's possible because they knew the design rationale behind metal printing. And when BMW, probably one of the first few to get into AM, they figured that out on their own. So it was a very simple case. When Nikon SLM supplied the machine, obviously they needed to ramp up the knowledge. Once they ramp up the knowledge of how to operate the machine, they say, thank you, I will take it from here because everything I'm going to do now is proprietary, it's my IP, it's my patent, it's my design. They don't want anyone to know about it. And that's exactly how companies who know how to make use of that is the powerful tool. It's not the hardware per se. Yes, of course, printers of different specs and scales have different impact, different outcomes, but it's really how you make use of it, the proprietary knowledge, how you master it. We always say, somebody could give you a sports car right here. If you have no idea how to drive it, you will crash it. Okay, so in the same way, you can have the most powerful printer, but if you don't have the IP, you don't have the knowledge how to master it, how to optimize and exploit the 3D printing technology, it will a white elephant. It'll just be a hardware sitting there. So to me, is people, companies need to really understand. They need to see which is the right technology. It may not be laser powder bed fusion. It could be something else. But if it matches your needs, you have the design, you have the product, you get in early. This is just a matter of time that you then have the competitive edge. It's not about. I always say it's not about. It's not about buying equipment and trying to justify the ROI. It's whether you want to invest for your future strategic advantage. You want to survive. If you want to thrive, you need to invest in this strategic advantage. That will be metal 3D printing.
Thank you so much, Gary. So let's give him a round of applause. Thank you. Sally, you want to add?
So what Gary say? So they should look for consultation service, right?
Yeah. Yeah. Okay. Yeah. So Vada, you have any point for this question?
Yeah, I think I do see that the machines are evolving. Okay, and what 3D printing machine 5 years back, now the technology is evolving, the cost is reducing. So I do believe that over time, if 3D the AM side, the machine costs can be brought down. Maybe the number of users increase, the volume increases, thereby the cost can reduce, then the adaptability will be higher. Okay. And again, more options will also be, depending upon. Again, for AM side, there are so many new technologies are developing, like DED is coming up. Okay, people are looking at the DED and the AM. Both of them are similar, but it's different. Okay, so the technology is also evolving. The machines are evolving. Yeah, let's see how things go. It's an exciting time.
Yep. Thank you. Just want to add one point to Vada point is that is actually what happening. So initially the machine price is very expensive. The material is very expensive. It's because the mass is not there. The number of machine is not big enough. And the amount of material is not big enough. So that's why the cost is very high. But when there is more and more adoption, then the cost of everything would be lower. And one of the graphs that I always like to use to express 3D printing is that, let's say if you imagine the vertical axis is the cost of production, and the horizontal axis is the complexity of the part. So for traditional manufacturing, the curve would go like this, right? It increased, gradually and exponentially with the complexity of the part. But for AM, the curve is different. AM production, the curve would start from here and go down slowly and reduce with the complexity of the part. The cost of making it is reducing. And then the two curves, cross at one point. And what we are seeing is that point would move more toward the left and the right, my right side, because cost would be reduced, machine would be reduced. And I think in the next 5 years, we will see a lot of, interesting application happening, and let's see how the cost for AM reduce in the next 5 years. Munchen, you have to add.
Yeah, I do agree with what all the others panelists is mentioning. I think it's just about time. I think in earlier on some of the presentations, you've already seen how AM is actually disrupting those industry. But just to add on that, to give some examples, is that if you ever heard of hearing aids industry, so hearing aids industry is previously is all using traditional manufacturing to do it. And it completely switched to 3D printing method is in just a matter of months of time, from fully traditional into 3D printing. So that you see is that the advantages of additive manufacturing is actually bringing in. Once the applications is right, the technology is right, and it's about time, it can actually fully transform into additive manufacturing quickly. And this will actually, goes back to the lack of talent that's available in the market. So we in Materialize has also done a few kind of market surveys as to try to understand what are the barriers that are preventing people of adopting AM. And often the top one of the barriers that we see is that the availability of skill sets in the market itself. So I think that's a call to actions to the universities people as to try to provide more of the skilled workforce that's available in the market, and that will actually help to drive the adoptions of AM in the market. Because nowadays itself is that not only the students needs to understand of what traditional manufacturing is, but they need to also have an understanding of what additive manufacturing is, and from the economical point of view, which of the technologies is to use or to combine both of it. So that the industry is now looking at multidisciplinary kind of students, where you have the knowledge of AM, you have the knowledge of traditional manufacturing, knowledge of material sciences out of it, and then also understanding the economical point of view of using which technology itself. And with the availability of workforce that's in the market out of it, that will greatly help the industrial to actually move forward and to adopt an AM.
Thank you so much. Let's give him a round of applause for the great answer. Now let me open the question to the audience. If you come from, can you introduce a little bit like what industry you're from, and is there any product that you want to develop using AM? Please let us know, and let us know the question so that all the panelists here can address. Mời anh Tri. Please, the microphone is coming.
Okay, my name is Tri. I come from Ho Chi Minh City University of Technology and Education. So I am really interested with on the present this afternoon, this morning. And as Gary talked about the advantage of 3D printing, somehow like we can, as I understand what you are talking is somehow we can integrate our creation to our product, even in not only for the design but also for the manufacturing process, so that's to highlight the value of the product, somehow like that one. And you also said about the thermal stress during making the device somehow. So I think that is big difference with the traditional manufacturing process. Somehow it will be the workpiece already treated, so that it can release all residual stress inside, so that it can maintain the tolerance of the product. However, for 3D printing, as I saw your in the presentation, that we had to use the heat source somehow to melt down the material somehow, layer by layer like that one. And you also need to use to make it cool very fast somehow. So it might create some residual stress inside the product. So this is that's what is the problem, is the difficulty in 3D printing technology.
Yep. So I think that's one of it. So what you said is correct. So as they lay the powder material layer by layer, and then of course the lasers, 700 watts, 1,000 watts. So they're obviously doing the melting layer by layer. So that creates a lot of heat, right? And then of course, finally, the full 3D product is fully formed. So of course, that is already in a very high temperature because of obviously the lasers melting and melting the powder and all. So after that, it needs to cool down. It can't cool down too fast, but it has to cool down depending on how big the product is. It could be by hours, it could even be days, depending. And so one of the things is that I think we must understand that additive manufacturing does not replace the entire subtractive manufacturing process. It has to work hand in hand. It's just that there are certain processes in subtractive that additive AM can do better, can do faster, and in some cases can even do cheaper. Okay? But we need to find that sweet spot. And when that sweet spot of AM goes into the entire manufacturing process, which we now like to call advanced manufacturing because we're using AM, using AI, using robotics, but subtractive sometimes will still have to stay. Whether it's the post-processing, whether you have to do a little bit of shaping, refining, and all that. So when all this comes into play, it will help you tremendously. It will help the company, it will help the industry tremendously because just giving an example of just now the same part, the hinge that I was talking about BMW. So that part is produced up to 60,000 pieces in 1 year. So most people have thought that 3D printing is only for prototyping, maybe by the hundreds, the most maybe by the thousands. But if you can achieve up to 60,000, and this is not by me, but this is done by an industrial customer, BMW, and they are profitable, and this is to replace a plastic part using metal, that shows something. That shows that this technology is real. It is not fake in that sense. It is not only for research or prototyping, it is actually for what we call series production. It is for end part production. And so to your point, yes, that is one of the challenges, the stresses, and there are hundreds, probably close to 100 over parameters that will affect the printing at any one time. But that's where the OEM comes in. Example, in Nikon's SLM solutions, that's where all our sensors, our parameters, basically, and all the the tracking, basically the sensor and the monitoring, that's the word, will come into play, and then give you basically the readings, the data. And it's from these data where, as I mentioned earlier, the IP, the experience involved, that you know how to play around with this data, the parameters, and then you fine-tune it to reach your optimum performance. So that is why it is a lot more difficult. It is the threshold of the entry, the barriers to entry is a bit difficult, a bit high, but once you get the right people, the right mindset, as I mentioned, in terms of design for AM, then you'll be smoother sailing at the later part. I will tell you that the first 1 year is not going to be easy. I'm not going to lie to you and say, oh yeah, it's a walk in the park. No, the first 1 year requires a lot of ramp up. But that ramp up is not about just understanding the machine. It's really the people, and the IP, technical knowledge, understanding the characteristic of how metal 3D printing works. And once you master it, then it's just like fire. You either know how to make use of it, or it will, overwhelm you, right? So if you know how to make use of it, it will become a perfect tool for you to do whatever you want. Yeah.
Okay, thank you. And may I have one more question? As we might know that in some structure like energy absorption for collection, somehow like that one. So the structure quite complex. Somehow we want to fill the hollow structure by the foam, and recently they use the metal foam. So somehow like that one. So we can make the structure with different density and different combination of material inside one structure. Can we make like that one?
So you're saying different materials within the same 3D printing process?
Yeah.
Okay, so currently most 3D printing technology is based on one single material. However, there is multi-material technology that is already available. There's only a few companies. Nikon SLM does have that technology, but it's still in a beta stage, right? So it's not fully commercialized yet. So it can't be purchased, still in the beta stage. So we can have two materials. So for example, you could have maybe Inconel, and you can have copper, you can have steel and something else. So or even more, maybe 3 materials, 4 materials, and it can be concurrently printed according to how you want it. So that is really the next level of 3D printing. But as of now, in terms of mass market, not mass market, but matured printing technology, it has to be a single material for now.
Okay, thank you very much. Yeah.
Thank you for your question. I think regarding your first question, I think Vada can give a good answer to address the issue of thermal distortion in printing a part, maybe. Vada.
I think what Nikon said is correct. Okay, 3D printing, this AM and the subtractive and additive manufacturing will continue to be like that only. Okay, one is not replacing the another things. But we have seen in our experience, there are people where I've seen in Singapore where the customer is making a drill bit. Okay, offshore the drilling. So they make the basic part using a machining. But on top of it, they do the additive manufacturing to create the cutter portion of it. Okay, so it's a combination. The industry will continue to be like that. Okay, but one thing I want to inform the professor is that this additive manufacturing produces a thermal stress, but also subtractive machining also produces stresses. Okay, because the cutting process also create stresses. Okay, when you are going to drill a hole, it's going to create stresses there. Okay, so it is not that the subtractive machining doesn't produce stresses. Both of them produce stresses. How do you manage it? How do you simulate it? How do you see the performance against the operating conditions? That is what is to be considered. But in all, subtractive and additive manufacturing will go together. And sometimes you do the subtractive manufacturing, machining, then you add additive manufacturing to complete the part. So the technology is evolving. It's an exciting thing as long as you understand what the engineering wants to do, what is the expected performance. We will have multiple design options and multiple simulation options.
Thank you. I think we are running out of time, so would like to have one last question from the audience.
Hello, my name is Vinh. I am calling myself a 3D printing enthusiast, and I am a content creator in Vietnam about 3D printing. My channel is Tennis AM, and I am trying to spread the information and the knowledge about 3D printing in Vietnamese market. So I really thank you, all of you, for the very interesting session. This is a great opportunity for all of us to learn more about 3D printing. And I want to addressing the point that Moon Chun talked about when about the application of 3D printing is limited by the skill and the knowledge of people. So in Vietnam, we have, like myself, I have a really limited reach to metal 3D printing and higher material and technologies. Also for a lot of university in Vietnam, we don't have, most of the students doesn't have the opportunity to actually work with 3D printer and more complex technologies. So how will you, great company, big company in 3D printing can do to support the university and students and people in many countries to learn more about 3D printing? I think this workshop is one of the things that you are trying to do, right? So in the future, maybe how will you spread the knowledge and spread the opportunity for all of the students learn more about 3D printing to close the gap between theory and actual?
Thank you so much. That's a great question. So for this question, I like each of you to have 30 seconds to answer.
Manchun will donate a printer for you. No, just kidding. But no, I think it's not an easy question, because I think it's a combination of how the government, the universities, and the industry will have to work together. Many countries, I can tell you right now, whether it's Singapore, Korea, India, Australia, or even Japan, they all.
I am a passionate of the 3D technology, especially in 3D technology, 3D printer. I started selling the first printer in Vietnam in 2003, and our company started in 2005. That is, today I would like to share some information about the 3D technology in medicine. So we already saw the presentation of Dr. Dung, and you can see that many successful cases and application of 3D printer for medicine in Vietnam, especially in Center 3D Technology in Vinmec. And now I would like to share some information in the world. And I would like to share what technology is proper for method 3D in medicine. So my presentation has 4 parts. The first one, why AM in medical, and the second one is what technology should be good for medical application, because we know that there are many technology in metal printing nowadays, laser or electron beam. And we share the medical business cases. And finally, we would like to introduce you who is Colibrum additive. So why AM in medical? I don't need to say more, because Dr. Dung already said, yeah. You know that
15,000 standards globally. So in the world, we have 34,000 members and signing more than 110 MOUs globally with different countries. So this is a quick overview of who we are. And on the right, you can see the roadmap about our presence globally. So let's go into the strict focus. So among all the 100+ committees, we have this F42 committees focused on developing international standards dedicated for AM, additive manufacturing. So we established this committee since 2009, which is currently one of the oldest and the largest committee on AM in the world. So up to date, for this committee itself, we have more than 1,300 members globally, and we already published more than 72 standards, and another 62 standards are under development. So in 2011, ASTM signed a joint agreement with ISO, which under their committee is called TC261, which means from 2011 onwards, all the global AM standard will be ISO and ASTM joint standard, which I'm going to show a few key examples at my later slides. So you may asking how we develop our international standard. So actually for ASTM, every year we host 2 global meetings, one within US and one outside US. So as you can see in Asia, we also had meetings in Tokyo, Singapore, Korea, and actually next year we are going to Philippines. So during the meeting, people will actually vote and confirm the final published standards across the global attendees and the participants. Okay, without further ado, let me briefly introduce some of the key standards. And before I move on to details, I want to quickly share there are actually different types of standard coming from the complete standard, such as what AIE shared earlier. For a company like GE, they may have their own standard. And after that, there may be consortia standard, which means a few companies or a few parties join together, forming their standard. And moving the next, you will have industry standard, such as aerospace, medical industry or automobile industries may have their industry standard. And after that, you will have government standard. For example, US has the US internal standard. For Vietnam market, there will also be specific country-driven standard. And then lastly, we will have our global voluntary consensus standard, such as all the ASTM and ISO standard. So in the next few slides, I'm going to show you a few examples of the key standard relevant to AM progress and development. And I will and where all the ASTM ISO standard sit here. So first of all, I would like to give you a quick overview of, I will say, the top 5 standard if you are actually printing metal AM. And up to date, I think there are actually more than 20 to 30 standards already published. So I picked probably top 5 standard for everybody's reference, and you can actually learn and learn from the standard. So first, we have this ISO ASTM 52.
So in this platform, you can input all the data of one project from material, manpower, and what software we use in this of the project. Okay, so I would like to show you one case study that has again applied ID. This is one case accident, and the hips on portion were broken. So firstly, patient will diagnose by CT scan to get decom image. After we have decom image, Hexagon have one we have the software to convert decom image to the mesh. After that, based on this mesh, we do simulation for 3D printing. After that, we do the real 3D printing. After we have the actual part, Hexagon have equipment to check again the quality of 3D printing by our scanner. And after inspection, the joint is ready for using. Okay, thank you, everyone. So if you have any, maybe in the morning, our colleague, my master already talked to everyone, Mr. Vara and Mr. Cameron. So if you have any question, you can contact with us. Thank you.
Thank you so much, Mr. Levan Fu. It's absolutely very interesting. And this presentation also clears the first part of this afternoon. We'll have a short tea break before the second part. And we have already prepared a tea break for all of you. Please feel free.
Is about medical application. So let's start first with the medical application question. My first question would be to Professor Dr. Trần Trung Dũng for his amazing presentation on some of the actual application in healthcare in Vietnam. And very happy that in Vietnam there's such an organization that leading the way in applying 3D printing in healthcare, or more specifically with medical implant. So my question would be, when you apply 3D printing in healthcare sector, what are the biggest challenge that you face so far? And what do you think the future, the next couple of years, how the future would look like?
Okay, thank you for your question. And as I mentioned in my presentation, I think that's in Vietnam, so many people want to apply 3D technology in medicine. So many doctors and so many engineers and company want to apply it, but we have so many barriers. The first one we understand that's the high cost of the 3D printing, because in medicine, you know, that's the personalization is a trend, is a hot trend, and we use the 3D printing technology in medicine must be the individualized. Therefore, the high cost. It's a very expensive. And the second one is that's quite difficult to team up with. For example, the doctor and the engineer working together. The doctor give the person, and the doctor and engineer will have to discuss to figure out the solution. And the third barrier is that the hardware and software is very expensive. Very expensive, so not easy to have the machine, have the software, and therefore so many barriers to prevent the applying 3D technology in Vietnam. And we try to find the solution for it. The first point, I think the most important point is that we have to team up to be a group, doctor, engineer, and to work together. So far, in my center, we have a 3D group with the 4 engineers, a designer, and the operation machine operator, and work together with
replace method, and the result fantastic. Even like they reduce the order. In fact, the one part can last even longer. This is just like 2 significant cases. Of course, we have many cases. We served aerospace, and there's more thing even today for the OEM they are using. I quote example. You all read the article like GE to launch their new GE X engine, and this engine itself already more than 100 parts 3D printed, which is all metal. Just like people doing it, OEM doing it. You mentioned about Makino. Yes, I saw the Makino machine. Their GM also talked to me, asked like whether we can adopt their DED. We all know like DMG, they are all 3D printer. We all know like a Solid, they are 3D printer. We all know like a Chrome, they have a 3D print. Why? The reasons like same back to the function I saying, 3D print is not option. All the OEM, they bet like 3D print is going to happen for the next 10 years, 20 years, 30 years from the all various industry. What we do today is like have to slowly to pick up to know how. This process not easy, really not easy. But from the different industrial perspective, people start using. GE to acquire the company called Concept Laser.
you share the Arcam also acquired by GE.